Hello and most welcome to 945, and I will continue with Susie Frobel because it is just incredibly amazing to use a little bit of superlative here. How could I put this? It is like opening a new door, and all what we've learned before becomes deepened, and we don't have to reject anything. It can all stay in the same singular place, but we deepen the understanding we already have. Let me continue with Bergson. It is a philosopher that is much neglected in modern times, and it actually needs his very specific and specific and general interest. And his take on time, I wish I read it before I started to look into times from a more limited perspective that I later did. The internal duration is the continuous life of a recollection which extends the past into the present, so that the present may clearly contain the perpetually expanding image of the past. Without this continuing existence of the past in the present, there will be no duration, only the existence of the moment. Systemic wholes display extended yet, from an endo-perspective, indivisible temporal perspectives. The internal fractal structure in the shape of nested detail becomes invisible to the endo-observer when those nested interfaces have merged into one boundary. We may say that for an endo-observer, his world-observer boundary expands and is shifted outwards when it incorporates a model of the observer himself and his environment. An exo-observer also uses models, but he does not incorporate them. They are part of his environment and thus beyond his world-observer boundary. In the terminology of anticipatory systems theory, an endo-observer who has constructed or incorporated a model of himself and in his environment displays what Dubois denotes as a strong anticipation or endo-anticipation. Dubois defines an anticipatory system as a system that computes its current states in taking into account not only its past and present states, but also its potential future states. Weak anticipation or exo-anticipation, by contrast, merely requires an observer to use a model of the external system for which he intends to make a prediction. An example of exo-anticipation is weather forecasting by means of a computer simulation. An example of endo-anticipation is human planning. Here, the future aim, which may be represented, for instance, by a diary entry marking the date of my birthday party, determines the action which temporally precedes and leads to the envisaged event: contacting friends, writing invitations, shopping for food and drink, etc. In a way, we may say that in this case, the future event caused my actions in the present, because I have announced a party which will take place in a month's time. I am now sitting at my desk writing invitation. This type of purpose-driven causation is also known as final causation or causa finalis. This notion goes back to Aristotle, who formulated 4 types of causation: formal, material, efficient, and final cause. The formal cause, causa formalis, the material cause, causa materialis, and the efficient cause, causa efficiens, explain what, out of what, and why something is happening in the present as a result of past events. The final cause, causa finalis, on the other hand, is goal-directed. It explains to what purpose something is happening in the present. So it is the future which determines the course of events. Today, final causation plays an essential part in Dubois' anticipatory systems, which pay tribute to both the causa efficiens and the causa finalis, by posing both questions: as a result of what and to what purpose does the present state arise? Both types of causal relations are also at work in nested systems in which memory and anticipation determine present decision, as was the case in Husserl's example of how we manage to perceive a tune. See chapter 2. I can make a small recap of how we perceive time. In music, we both have the start and we have the end, and we have the melody going in between the two things. And all these 3 things are present simultaneously: the future, the past, and the now. And you can also see here how the logocentric idea of metaphysics of present can cause a problem here, a sort of limitation that is handicapping what you take to be future, past, and now. And all 3 will come under problematic guise. Both types of causal relations are also at work in nested systems in which memory and anticipation determine present decisions, as was the case in Husserl's example of how we manage to perceive a tune. My theory of fractal time, the first part of which I will briefly present in chapter 2, also attributes causal relations in delta t length, that is to say between successive events, unless they are arranged against the background of an embedding or overlapping simultaneous event. An example of an embedding event can be found in Boujaki's observation that global slow oscillations modulate faster local events. Another example would be the case of the missing fundamental, where our perception of nested high frequencies trigger the emergence of embedding lower ones. Overlapping events occur when we remember the past and anticipate the future in our now. So retentions and protensions merge into one nested temporal structure. Strong or endo-anticipation implies that longer temporal intervals can influence embedded shorter ones, and the shorter intervals can influence longer embedded ones. Along with these directions of causation from the inside to the outside, and vice versa, come boundary shifts which create new systemic holes by extending or reducing the original system. For instance, a walker using a stick, or a patient for whom a spatial hemisphere is lacking. In this context, it is interesting that for Dubois, anticipation and delay play complementary roles. We shall extrapolate on this idea in Chapter 11. Chapter 11, we have a lot in the future to look forward when it comes to the most marvelous book by Susie Froebel. I think I should move position here. Some of the examples above refer to a nested temporal perception, others to external nested structures. When internal rhythms lock into external ones and vice versa, we can determine the accompanying boundary shift in terms of the boundary complexity introduced earlier in this chapter. Sometimes a boundary arises from an interference pattern created by internal rhythms which overlap the external ones. An example is interference patterns arising from autoacoustic emissions. That is to say, the measurable sounds emerging from the air. David Camp suggests that no incoming signal would be perceived unless the receiver also produces a signal. An outgoing one which interferes with the incoming air pressure waves. This is oddly one of those things that I actually was aware of. As a joke, I said to a doctor who was a specialist in hearing problems when I still was working for the hearing impaired organization, and I said jokingly to him, well, we have a lot of patients where you cannot hear the tinnitus, and he just looked at me seriously. Well, there are only 10% of tinnitus sufferers where you can actually hear the tone from an outsider. Now it turns out everyone are producing tones. We also produce vision. It is mostly coming from inside the thing that we have on the outside. There are clear light signals, and in the very interference with the outside exogenous world that we can get vision. We don't send any signals out, we will get very little or any information at all. Perception is not passive but active. What we perceive are the interference patterns of outgoing and incoming waves. Anthony Moore suggests that this would demonstrate how certain physical aspects of hearing take place outside the body at the entrance of the ear, thus shifting the boundary between oneself and the world outwards as an ethereal scheme of interferences. Interference it should be. Before we look at more abstract types of boundaries in Chapter 5, where we introduce the notion of potential space, a few words on how specific boundaries are implicit in certain models and methods. We all use models of ourselves and the outside world, consciously or unconsciously, and are usually not aware of the fact that we implicitly assume a division between the observer and the observed, namely a boundary which separates the inside from the outside. Depending on our epistemological approach, that is to say, what we assume we can know at all about the world, our models presuppose very different boundaries. To take two extreme positions, a naive realist believes that there is a real world outside his brain and body, which exists independent of any observer, including himself interacting with it. A radical constructivist, by contrast, assumes that reality is a construction of his brain and his interaction with a non-me, that is to say, the rest of the world, which includes other individuals and societies. Our models also differ greatly when we compare the view from within with an external viewpoint. The view from within corresponds to the phenomenological approach, which does not attempt to explain, but describes the world as experienced from the first-person perspective. Phenomenology deals with the world as it appears to us. It makes no claims about the nature of the noumenon, the world behind the phenomenon, and is thus deeply rooted in Kantian tradition, which is based on the idea that we have no access to thing in itself, but only to things as they appear to us as the phenomena. Thus, we have no access to the real world, should there be such a thing, but only to perceptions from which we may draw conclusions as to the nature of reality, which exists independent of anyone observing or participating in it. Apart from subjective experience, the phenomenologist is concerned with intentionalism, the purpose and intent inherent in and preceding all human interaction. But phenomenology is not a mere introspection beyond the internal viewpoint. It relates to the external world as a result of being nested into a physical, social, and cultural environment. In contrast to the first-person perspective of the endo-observer, a cognitive scientist may take the third-person perspective of a pseudo-external observer whose studies includes explanatory attempts based on psychological motivation, neurological correlations, and biological dispositions. I use the expression pseudo because no human being can ever be a pure external observer. Listen to that. Analytical philosophers. External. We are always embedded in social, culture, or linguistic frameworks. So the cognitive scientist is really also an endo-observer. External perspectives are idealization which are reserved for divinity or philosophical construct. A famous example of such a construct is Laplace's demon, and ideal observer invented in 1814 by the mathematician and astronomer Pierre-Simon de Laplace. This hypothetical entity is in the guise of a pure observer, does not interact with the system under observation, although he is part of that system. As a personification of determinism, he is able to compute the present state and predict all future states of the universe from the past and the present position and momentum of all its components. The vantage point of mortal observers, however, is located within the universe, embedded in time and space. Therefore, any attempt to describe temporal structures is limited by a priori contextual constraints, such as the corrective distortions discussed earlier, which shape our temporal perspectives. The phenomenological method proves to be a useful candidate for describing the structures of our temporal interfaces, as it allows us to focus on constraint and corrective distortions inherent in our perspective. It is so because the phenomenological procedure leaves aside brackets our potentially naive worldview, which takes the world for granted and forces us instead to question the role of our perceptions and consciousness play in the generation of reality. Furthermore, the method of phenomenological reduction, in the Latin term reducere, means to lead back to, and in this context refers to the way the world manifests itself to us, allows us to adopt the phenomenological attitude in which we are no longer primarily interested in what things are, in the weight, size, chemical composition, etc., but rather in how they appear, and thus as correlates our experience. So we are getting to the how question here. It's rather interesting. I can see a very clear parallel with Heidegger here. This approach not only allows for manifestations of our temporal perspectives such as subjective duration, but also for pseudo-external points of view and possible interconnections between levels of description. Examples are Douglas Hofstadter's strange loops or tangled hierarchies, which are described later in this chapter. Earlier we said that the way we perceive events depends to a large extent on the model we have of ourselves and the outside world. However, when it comes to modeling the world, we encounter very basic difficulties which cannot be circumvented. One major problem was nicely summed up by Norbert Wiener's observation that the best material model of a cat is another, preferably the same cat. Because a model never compromises all aspects of a system, we are always forced to deal with an abstraction. As human beings, we have limited time and resources, and as a result of our subjective perspectives, limited access to the world. So when we model a system and make predictions, our pragmatic approach, and as a result, is to focus on one parameter or a few parameters only and to disregard others. To forecast the weather, for instance, we feed a limited number of parameters into a simulation program. We may include parameters such as temperature, air pressure, and prevailing winds, but we'll stop short of including every motion of the planet, such as the flapping of a butterfly's wings. We proceed in this way for practical reasons, although we know that the butterfly effect may well be that decisive tiny impact which tips the weather system to develop into full-blown hurricane or a calm and sunny day. In this book, we are primarily interested in internal models, or in Du Bois' terms, the property of a strong anticipation. This property determines human behavior and is found in all structures or processes which contain a model of themselves and their environment, and refine those models by interacting with their environment. Depending on our choice of methods and models, the boundaries which define inside and outside are set at very different locations. Let us take a brief look at free cuts, which all connects and separates inside and outside, but rest on very different worldviews: the Cartesian cut, the Heisenberg cut, and the Rössle cut. Next, we proceed via Einstein's relativistic observer frames to Otto Rössle's endophysics and Roger Boskovich's covariance principle. Finally, we shall take a brief excursion into Douglas Hofstadter's tangled higher class in order to work out differences between internal and external temporal perspectives. For our purposes, that is to say, to describe temporal perspectives, the following descriptive features shall suffice to differentiate between cuts, interfaces, and boundaries. A cut creates separate worlds and is therefore a philosophical division. An example is the Cartesian dualism, which divided human beings into two separate realms: the mental and the physical. An interface, on the other hand, is an interactive filter which connects systems. These may be as diverse as social organizations, computers, life, worlds, boundary surfaces in chemistry, biofilms, or software. I define a boundary as an extended field which connects and separates systemic wholes and may consist of a number of nested interfaces. The first cut we consider here is a division which has had a substantial impact on Western science: the Cartesian cut. In the 17th century, René Descartes distinguished things physically from things mental, res extensa and res cogitans, and thereby created the mind-body problem, which deals with the question as to how to relate to each other. Although Descartes' division has shaped...
Hello.
Yes, Kenneth.
Baru juga explode soal kalau. Nah, aku dah nak belakang dia.
and thereby created the mind-body problem.
Tidak kan soalnya. Tiga anda kalasnya.
Although Descartes' division has shaped our scientific theories for centuries, recent advances in cognition and embodiment suggest that the Cartesian cut is not a helpful model. The mind is embodied. That is to say, our cognitive performances are constrained by our limited perceptual apparatus and by metaphors which are directly linked to our sensory motor system. George Lakoff and Rafael Núñez have described some of these constraints in their seminal work of embodied mathematics. A very simple example is embodied arithmetic, which is based on the idea that there is a precise mapping from the domain of physical objects to the domain of numbers. Examples of such mapping includes addition as adding objects to a collection, subtraction as taking objects away from a collection, sets as containers, members of sets as objects in a container. Another example is how counting with our 10 fingers invites us to use grouping, ordering, and memory capacity, which creatures without fingers would be very probably have not evolved. Lakoff and Núñez suggest that such regular correlations result in neural connections between senso-motor physical operations like taking away objects from a collection and arithmetic operations like the subtraction of one number from another. Such neural connections, we believe, constitute a conceptual metaphor at a neural level. In this case, the metaphor that arithmetic is object collection. As our models are based on abstractions constrained by our sensory motor system and the resulting conceptual metaphors, the Cartesian cut between res cogitans and res extensa is, in the light of the embodied mind, not a useful model to describe our temporal perspectives. Einstein's interfacial cut, which came in the shape of observer frames, whose relative position and motion determine the successive order of events and measured simultaneity, is necessary but not sufficient ingredient for modeling a temporal perspective. It is not sufficient because the relativistic notion of a temporal observer frame does not take account of either the interference any act of observation implies on the micro level, nor of the observer's internal microscopic differentiation. The first issue was encountered in quantum theory, which set the Heisenberg cut, and the second in endophysics, introducing the Rössler cut. I have a keen sensation this is going to be more and more interesting. At first sight, the Heisenberg cuts shift the line of division between the observer and the observed towards the outside. It seems to be no longer division between mental and physical things, as performed by the Cartesian cut, but rather a separation of the observer and the observed, with the measuring chain usually attributed to the system observer. However, on closer inspection, the Heisenberg cut is not completely disjoint from Descartes' cut between the mental and the physical world. The outcome on the measurement depends, after all, on the decision as to where exactly the cut is located. And that decision is usually made by a flesh and blood human being with working cognitive functions. It is by no means a trivial matter to decide where the measuring chain ends and the object to be observed begins. We can see the difficulty already in the comparatively transparent example of the unilateral neglect patient, who used a stick for reaching and thereby virtually double his event horizon. He was able to perceive and control the so far neglected hemisphere, because the use of the two led to remapping in his brain of far space to near space. So far, we have pretended that something like an observer exists who can scrutinize the system without influencing it. But quantum theory shows that measuring means interfering. Whether we probe a system by shooting light at it or electrons, as we do in microscopy, or sound waves in a sonographic measurement, the principle is the same. We throw something in the direction of the phenomenon we want to measure and draw conclusions about the nature of phenomenon by interpreting the interference pattern produced by our disturbance and the system's reaction to that disturbance. Any act of observation at that level is, in fact, an interference, just as measurement is. So there are no pure observers at the quantum level, but only observer participant, since in every observation the observer is also an actor. That is to say, he participates in the system. So this may be a convenient point at which to abandon the notion of a pure observer for all practical purposes, and henceforth talk of observer participants. Observer participancy blurs the separation between inside and outside, mind and matter, subject and object. On the macro level, this dichotomy is blurred only if we take account of the observed participants' macroscopic movements. Enter the Rössler micro-relativity, which separates the inside from the outside. That is to say, the observer participant from the rest of the world. The Rössler cut divides the world into endo and exo, the view from within and the view from outside. This new cut originated from Rössler's endophysics, which describes physics from within. That is, a physics which includes the observed participant, in other words, the macroscopic movement in its current physical state, and is described from that observed participant's perspective. I think this is a good time to end. Here it starts to rain. And I wish you a very pleasant afternoon. Bye bye for now.